Hi everyone, my name is Urvin and today I'm making this video to demonstrate a tutorial on based on how to complete our task 3.1p, which is based on a terrarium in which we will build an embedded system which will notify us through the emails that whether the light has been detected or has been stopped whenever the lux is reached above or below the threshold. And this is our whole 3.1p. So let's talk about what is 3.1p. So in this, we are aiming to build an embedded system that uses the Arduino to measure the amount of sunlight, and hence here we will be using the Node-RED protocol instead of IFTT because it's a paid version. However, Node-RED is just open source application similar to IFTT but with many enhanced features. Although it is a bit difficult to understand in the starting, but if you are able to cooperate with it, then it is really better than IFTT. I can say and I can agree on that. So let's move to the PPT. Here we will be developing this terrarium sunlight monitoring with Arduino and Node-RED. So here are task requirements. These are task requirements which I have already discussed because I have used the Node-RED over here. So talking about the hardware used here, we are using the Arduino Nano 33 IoT as our main controller, and there is one BH1750 which is the ambient light sensor which will measure the light in the value of lux. And I will also like to mention that how is the Node-RED used? So here we have an inbuilt Wi-Fi Nina W102 module, which is a Wi-Fi module which is inbuilt in the microcontroller itself, and which lets us to use the Wi-Fi and to connect to the IP address of the laptop and then to send the values from the microcontroller to the Node-RED. So that's how this Wi-Fi module is really essential. So let's talk about the software part used here. So first of all, uh, whenever we are implementing any embedded system, we are providing some instructions to our microcontroller on how to perform certain instructions there. So whenever we are starting with any sort of embedded system, we are providing some sort of instructions to our microcontroller on how to act, think, or sense. So this Arduino IDE is really an essential software here because it's an integrated development environment through which we will be writing our instructions by using some sort of libraries, and those libraries has some other built-in functions that we will be using, and later on I will also be discussing that in the code part when I'll be explaining that. So you can see Arduino IDE, it's a software for programming the Arduino boards, which I have already discussed now, and it allows us to write, compile, and then just upload that code to the microcontroller. So the next software uses the Node-RED itself, and Node-RED is an I have already discussed. It's an open source, and it is based on the Node.js because we will be using certain nodes to build our whole protocol on how, let's say, like there's a really difference in the IFTT and this Node-RED, and because we have a lot of customizations available in the Node-RED, and by joining different types of nodes, we can create our own function on how we want the things to go, and I will also be discussing that part too. Here, if you can see, it's a browser-based editor that allows us to connect the hardware devices. So that's how we will be connecting a microcontroller to the Node-RED via Wi-Fi module. The Wi-Fi module will get the IP address of the Wi-Fi to connect to the Node-RED. So so I would also like to mention that to install the Node-RED, you must open your command prompt, like by typing here command prompt and just running this command to install the Node-RED package. So Then I will also show you how to run it. First of all, this is the code for installing the Node-RED. So let's move to the system workflow, how the system will work. So here, first of all, we will be building our Arduino sketch. This is our Arduino sketch. That what this sketch is. Sketch is the instructions that these are the instructions that provides us the values of the light. Like we have this code, this Arduino code, and this Arduino code generally do is to get the values from the light sensor, and these values are then given to the microcontroller, and from the microcontroller we are getting it to our system, and also these values are being passed on to the node-RED via using the IP address. So you can see uh, the sensor measures the lux values, and the Arduino reads that, and then the Arduino sends the JSON, because these readings are being sent to the node-RED via a HTTP post command in the format of JSON. JSON is a format which is used to give the values to the node-RED. So here the function nodes will check. This is a node. This is a node, and it will check whether the value is above or below the threshold, and if the threshold if the value is above the threshold, then an email will be sent, and if the value is below the threshold, then again the email will be sent, and that's how our whole embedded system we are required to build, and hence we will get an email, you can see over here. So let us check about the highlights, the Arduino code basically. Here you can see the first part. It connects to the Wi-Fi. You can see over here in the void setup, you may see we have begun the serial dot begin so as to establish the serial monitor and to get the readings by printing them in the serial monitor. And this is the wire dot begin to begin our I2C protocol, because our our BH1750 is an I2C based sensor, and we use generally two types of pins which are A4 and A5, and these are the analog pins which reads the bits ranging from 0 to 1023 bits. And talking more about the I2C, I would like to say I2C stands for the inter-integrated circuit, because it's a two-wire protocol, and the main pins are the SDA and SCL. Here, over here, you can see, I will be, if it is visible in the camera, then you can see there are two pins, SDA and SCL. The SDA one is for the sending of serial data, which will send the data, and the SCL stands for the serial clock, which synchronizes the data according to the clock. So here you can see, this is the here is the string payload, how the value is sent to the node-RED. So this is the main highlight, and this is the whole flow. Now I would like to discuss the node-RED part. So you just I have already told you that you have to install the node-RED using that command, and I'll just simply open my command prompt and just write node hyphen red, then it will open the server of the node-RED. And here you can see our server is running at this port. This 1880 is our port on which our node-RED is running, and let's open that. Here you can see this is the whole interface of the node-RED, and these are the nodes that I have created over here. This is the post under which at the slash light, under that tag the values are being sent, and this is the JSON node which will receive our data in the form of JSON, and this is, and I would like to mention about is the function node. This function node tells us, is it is the main decision maker on whether to send the email. So this whole explains like it gets the value and then checks whether it is above or below the threshold. Once it is checked, then if it is below, then we'll get an email that the sunlight has been stopped, because low flux basically means that sunlight has been stopped. So it sends the email, then retains that value till further, and another value is detected which crosses the threshold above. So when that value is received, then again that part is checked through the if statements you can see over here. And if it crosses the threshold, then again we will receive an email that says sunlight has been detected along with the lux value over here. So this is our function node, and it is the main decision maker on how and when the email is sent. So this is the email node and this is the HTTP node. So I would also like to mention about the email node. Here you would enter any name to whom you want to send, and it must be a valid email. Through which server we are sending? We are basically using the Google SMTP server over here, which I would like to explain. So what is Google SMTP? So Google SMTP is just a service that lets me to send emails from my system using the Gmail, and in my project, the Node-RED connects to the Google SMTP server with my Gmail account, and that's how I'll get the email to my inbox. So this is my whole setup for the email node, and this is how we will create some wires between them, and that's a whole flow mechanism that I have made to get an email, and when to get an email and when not. So, okay, so let me cover the code part now. This is our Arduino sketch. We'll be using the basic libraries that are wire.h and bh1750.h. The wire.h is mainly for the I2C protocol, and this one is for the sensor we are using. We are basically using the BH1750 sensor, so we have to include that library so as to measure the values in the lux, and that's how we'll be using the Wi-Fi module to connect through to the Node-RED. And this is the HTTP client. Will Because we are using the HTTP server, so hence it is necessary to use that. So this is our Wi-Fi credentials. This is our Node-RED credentials. This is our IP address, and I would also like to mention how to fetch that IP address. So this IP address you can say can come from by opening your command prompt and just write ip.config, and here we'll get the IP address which is 10 this is our IP address, and it's unique for every Wi-Fi you are connecting. Make sure you stay with this same network throughout performing the project so as the IP address is not changed. So this is really necessary part to avoid any sort of issues that are occurring. So this is the port which I have also told that our server is running on this port, and here you can see the serial dot begin just begins our serial communication, and you can see the values on the serial monitor. Here wire dot begins the I2C communication, and here in the void setup you can see I have to set up my ambient light sensor, which is the BH1750, that it is working. So we'll get this printed in, which is BS1750 is ready, and else if we are facing any error, then we'll get this in our serial monitor. So moving further, we'll setting up our Wi-Fi, because connecting to the Wi-Fi is also necessary, and we'll get and this is a while loop that is repeated, and just try to connect to the Wi-Fi and just try, and if it is connected, then we'll move to the other loop function, which will fetch the lux values from the sensor, this prints on the serial monitor over here. You can see, and then if the values are fetched, and then the a string payload is created. It's a JSON format, it's value in JSON format, which will be sent to the node-RED, because in my code the payload is a JSON string that carries the light value, and in the node-RED this same payload is received, and then the function node over there decides when to send the email or not. So here you can see some basic commands of the HTTP library, the starting the HTTP server, and then where to send these values. I have already told you that I have a slash light tag in which under which we will be posting our values, and the client.send header will tell the node-RED we are sending a JSON value. Okay, so here you can see, the next and the next will tell the length, like how much is the length of the data in the JSON which is sent to the node, right? So here we will be start writing the body of the request, and then actually send the data with the lux value, and at last we will just end the request and wait for about 5 seconds, and this whole process is under the loop function, and this whole will be repeated again, and the function node over there will decide when to send, when to not, and this is the whole working you can see, and it's quite clear that if you haven't and if you are not aware about any of these softwares or any of these hardware, you can easily connect these using the Arduino, and just perform and complete the whole task in no time. And because I have discussed all the main points, but here I would also like to tell about how to do the sensor integration part over here. You can see we will connect our Arduino and the ambient light sensor over here. The SDA and SCL are defined on the A4 and A5, and then we'll connect and we will give the common grounds here, and then I'll connect the VCC of the 1750 to the 3.3 volt pin on the Arduino, because this sensor is suitable for handling voltages from 3 volts to 5 volt as per the data sheet. You can also search the data sheet on the Google by just simply typing the name of the sensor. I have it, this BH1750, and this is the sensor integration that I have made. So let's talk about the practical part. Let's uh, let's give 1 minute on how this project is working. So let me connect my sensor. You can see I have connected my Arduino with my system, and the sensor is now will be reading the values. First of all, I have to upload my Arduino sketch. Here I have uploaded my Arduino sketch. I will be closing my Node-RED, and I'll run that again because it is necessary to, if you want any updation in your code, then you must update the part from the IDE itself and then run the server again to observe the changes. Now is connected to the Wi-Fi. You can see now the we are getting the lux value over here after every 5 seconds. So part we'll open the command prompt, and then we'll write node-RED. You can see our server has been started on this. We'll open that. You here you can see a blue line appeared which told us sending. And you can see I have received a notification over here. It says that the sunlight has been stopped because I have kept my sensor under my notebook, so it is not getting any lux, and hence I have received the email that the sunlight has been stopped. So if it reaches above the 300 threshold, I'll again get an email that sunlight has been detected. So let's get this sensor in the sunlight. I'll just increase the light and I'll get over here. and you will see an email. Here you can see the sending part that has here. Now I'll get an email. Here you can see I have received the notification, and now it says that sunlight has been detected and the value of the lux is 1030 because the light has been detected. So I'll again switch off the light. Now I'll again, you can see it is sending and I'll receive an email that sunlight has been stopped. Here you can see. So thank you for watching. This is the whole setup tutorial on how to perform a 3.1p task without any issues. I will be providing the code and you have seen that I will provide the function code as well in the GitHub directory, so you can directly get it from there, and I'll mention it in my description. And this is how you can easily complete your 3.1p. Thank you for watching.